So in the lecture, I'll talk about how to use a heap data structure uh, to represent a function. And here I will revisit this concept. So first we have an operator that is plus, minus, division, um, multiplications, sine, cosine, and we have our terminal that is some value, uh, the unknown variable x, and for example, for sine, if we want to represent sine, then there's a problem since it's like unary operations. Then here I have sine of something, then I can place the something here in the left child, while on the right child there's nothing. So what I can do is I can create a special symbol. Let's say T means that this special symbol is like terminal, that we don't need to do anything here. So let's put T here, and once we have this, we can create our heap data structure. Um, let's make a table, or let's make a list. So I have, let's say the list, the index starts at 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and say if we want to create randomly generate a function, so we generate start from the root node. For example, if this is multiply, then I can create two child node, um, and here the multiply is indexed at 0, so we can put multiply here, and for a node that is indexed at k, let's say here is indexed at k, then we have the child, like in the heap data structure, we place its left child in index at 2k plus 1 and right child as 2k plus 2. So um, then we can randomly choose from whether it's an operators or a terminal. Uh, so let's say if I choose as a terminal, for example, plus, and here I choose, oh sorry, if I choose an operator like plus and a terminal as a 5 here, then that's indexed at 1 and 2, so I can put plus and 5 here. Then I can create the left and right child for this plus. For example, if I choose another operator that is, let's say cosine. Oh, cosine, and here I can choose a terminal or an operator. For example, if I choose x, then in your heap data structure, based on this, I can place it so 1, 2, times 1 plus 1, that is 3, and this one is 4, so I can place cosine here and place x here. Now I will need to choose the left and right child for whatever operators it is. So for cosine, what I can do is, for example, let's choose x as a terminal here, and since I have cosine, then the right terminal is automatically decided, and so this is a special symbol t indicating that's the end. And based on the indexing, that would be index x would be in place 2 times 3 plus 1, that would be 7, and this one would be 8. So we will place x in 7 and t in 8. Now, for example, what about calculating this thing, or what about writing it in like naturally understandable equation? So the way is to traverse it backwards. So we first find the largest index, the element, that is t, and then we will find its neighbor, and its neighbor based on this indexing is x. So, and also we will need to use this indexing to find its parent, and its parent, for example, um, for the parent of t, since 8 is an even number, it means it's um, a right node, and we can basically just use this. So that would be 8 minus 2 divided by 2, that would be 3. So its parent is actually what? Its parent is 3, index at 3, that is cosine. So now we have cosine x plus t, but t is like a special symbol, so we don't write t here. So here, now that would be what is represented in this tree, and we will find the neighbor for this uh, cosine thing. Then we can find that the neighbor is x based on the indexing, and also its parent is plus. Then we can write, so this is already like either a string or a result, then plus x. So basically you put, for example, if you are calculating the result, you put the result of your calculation here. That would be result of cosine x. Now find its neighbor, that is basically x. So its neighbor is x, then you will add this to here, that is cosine x plus x, and that would be this result. And if it is not the root node, then you will go to the upper level, like based on its parent and its neighbor. So here we place a result of cosine x plus x, that is this times 5, and that would be the expression or the result for the root node. So that's it.